Hello, and welcome. Good evening, good morning, good afternoon, good nap time, and good evening time, and good, hopefully, peaceful, relaxing night time to everybody. Thank you so much for joining. If you're going to be joining, thank you so much for watching this as a video upload later on. If that's what you're going to be doing, and indeed, I want to say welcome, welcome, welcome. Thank you so much for being here. And I'm very thankful and very grateful to see everybody old and new. Hope to meet many new friends today, as well as many returning friends if they are still up. It's a little bit late. I did have a bit of an upset stomach this evening, which came about in an unprecedented manner. Indeed, I was at the gym and I couldn't even finish my usual workout, and I had to come back after I lifted some weights, and I did not do my swimming, which made me very sad indeed, because I had to rush back with unprecedented urgency. And yes, so yeah, I think it's because oh, thank you so much, guys. Thank you for liking the live. Thank you, thank you, thank you. Thank you for the hearts and emojis and sending the little hearts that I see floating up. Thank you so much. Love it. Thank you, Gary. Thank you, Maxi Ghost. Thank you, Stephen. Thank you, everybody. Thank you for liking the live. Oh my gosh. Oh, I love it. Oh, I love it. Okay. So we are talking about the universe and its origin and fate as described by Stephen Hawking's book, Brief History of Time. And we've been seeing how there's been some difficulty with the singularity that is the Big Bang, from which we, of course, start, and various models, inflationary model and this model and that model, which would basically lead to our current understanding of the universe and certain important questions that we have about the universe that we kind of covered a few lives ago, where certain things about the universe, let's just say, are very finely balanced. Basically, there are some numbers, including, for example, the charge of the electron, or, the number of baryons, the ratios of various things, such as in the cosmic inventory, dark energy, dark matter, normal matter, or baryons, neutrinos, photons. All of these things are sort of cosmically finely balanced to give us the universe that we live in today. And we have certain questions, especially also about the expansion of the universe. And Fuji Baba, Shona. Fuji is wanting to get my attention. Fuji Mama's here, Shona. I know it's not a coincidence that I discover you now. It's a causality. I always love your positive attitude, and your intelligence knows no limits. Gary, thank you. Thank you, Gary. Mexi Ghost says, I'll be back. Gonna make some PB&J. Yes, please come back. Yes, thank you so much for being here. Welcome to the live. Thank you. And I hope that many of you will stay and participate and listen to the conversation, or say something in the chat as well. So we have some questions about the finely balanced nature of the universe, and also about how the expansion of the universe is also very unique. It could have been expanding in a way that basically leads to a recollapse. So if the universe did not expand fast enough, then we could have recollapsed. If the universe expanded too fast, then we'll never recollapse. And also certain other things would be difficult. For example, why does the cosmic microwave background temperature is quite isotropic and homogeneous no matter where you look in the universe and no matter what direction you look in? So, because that would imply that back in the day when the universe was more young, early days of the universe, and I really don't want to say days because it might even be moments, depending on which part of the universe evolution you're talking about, or it could be millions of years or even hundreds of thousands of years. For example, the CMB, we consider it to be around 300,000 years, when the universe was 300,000 years old. So the cosmic microwave background is considered to be this primordial. I love this stream because I love astronomy. Thank you, of course. Thank you for being here, everybody. Stephen, Gary, everybody, love it. The cosmic microwave background temperature, or the cosmic microwave background photons, is considered to be a primordial sort of photon signature, but actually the universe was around 300,000 years old at that point. So again, it depends. It's sort of relative what you mean by the timelines of things in the universe and its evolution. But earlier on, the universe was not as expanded because the expansion has been happening, and there may have been time for light to reach from one region to another, so much so that the photons in the cosmic microwave background have the same temperature, for example. But that too was a question that we've been kind of exploring in this chapter. So questions like that and discussions like that about the universe is what this chapter has been about, and we will continue with it and see what else we find here. But those types of things are really things that you can't really take for granted in the universe because you know, the CMB temperature being homogeneous, isotropic. Sometimes we call it the smooth universe, but then of course, even the smooth universe actually has certain little irregularities or spots of overdensities, which has led to, of course, the stars and the galaxies in the universe. And exactly how those overdensities came to be, how we have those irregularities, again, is a question as well. And what kind of drives them is another whole topic that we will get into at some point. So these are all little things, or they're not really little, but they're details that are worth investigating because it actually makes our universe quite interesting and unique. And the more we can understand, the better, because they don't seem to be, such a coincidence.